Video lecture 3 on amino acids and finding their isoelectric point. The first video I went over the amino acids, kind of how I remembered them. In the second video I went over what isoelectric point is and how you find it. But I did a very brief, kind of just like a general, this is what an isoelectric point is, but this is going to get into a little bit more detail what happens if you have an amino acid with a side change that actually does have a charge. So this is my contact information. Again, cannot stress this enough. Feel free to reach out to me whenever, if you need help or if you have specific questions. I'd be happy to meet with you one-on-one, or even just respond to your question directly and maybe fix it through email or whatever. So isoelectric point, this video is going to cover isoelectric point for acidic and basic amino acids. Again, just a reminder, the isoelectric point is the point at which a molecule carries no net charge and is electrically neutral. And so here's the two examples we're going to look at, aspartic acid or aspartate and lysine. So immediately what you notice, this is also just a side note, it looks a little bit different than the other amino acids that I've shown you, but this is just kind of writing it like you would in organic chemistry. It still has, look, the carboxylic acid here, the central carbon with the hydrogen here, and then the amine group, and then this is the side chain coming off here. So this is typically what you'll actually be shown, in biochemistry and onward. So it's good to be able to interpret this or recognize the amino acids when they're written in this format. Same thing here, amino group, central carbon, carboxylic acid, and then a long chain with another amine group here. So lysine is going to go ahead and have a positive charge because this group can accept a proton, and another carboxylic acid over here in the side chain can donate its proton and become negatively charged. So what should pop out to you is that normally at biological pH, this is going to donate a proton and this is going to gain a proton. So these cancel each other out and they are, isoelectric, they're neutral. But what you're forgetting about is this can also donate a proton. So this will make it the overall molecule have a negative charge. Same thing here, this can gain a proton, so can this side chain, and then this goes ahead and donates a proton. So these two would cancel out, and then you're left with a positive charge here. So here's all the pKa's. Again, these can vary depending on textbooks and different studies and stuff like that. So make sure you defer to whatever your professor tells you or whatever you're given on the question. But this just requires a little bit of critical thinking. When you're thinking about finding an isoelectric point, you want to think about you're looking for the point where the overall charge of the molecule is 0. So where would that happen? Recall if the pH, the potential hydrogen, I'm going to say, is higher than the pKa, then it's going to go ahead and donate a proton to solution because the potential hydrogen is high, so it's going to donate a proton. So if pH is, let's just say 4. If pH is 4, this is going to donate its proton. It's also higher than this, so this will donate a proton. So that's a -2 charge, and this is going to gain a proton. So that's going to go ahead and cancel out one of those negative charges and be +1. So that doesn't really work. So let's think a little bit harder. What if the pH is 3? So 3 is below this pKa. So this will stay protonated. So that's going to be neutral. 3 is above this, so that'll donate its proton. 3 is also below this, so that will keep its proton. So it exists as NH3 with a plus charge. So these two will cancel out, and then this doesn't have a charge. So that could work. So that's where it'll be electrically neutral. So we should know that the PI or isoelectric point will be relatively low. Same thing over here. Let's use some critical thinking. If pH is 9, if pH is 9, this will go ahead and donate its proton. So will this. So this will exist as NH2, remember, because typically would have an NH, it'll exist as NH3. So this will be NH2. This will be negatively charged. And if it's 9, it's lower than this, so it's not enough to make this donate its proton. So this will still have a plus charge. So this will go ahead and actually that would work because this would have a plus charge, this would have a negative charge, and this would not have a proton, not take a proton from the solution. So finding the isoelectric point, it's the same formula, pKa1 plus pKa2 divided by 2, but you got to make sure you use the right pKa's. So going back here, you're going to use the pKa's that basically like where you think the isoelectric point is in between. So we know the isoelectric point just by like that reasoning that I just did. The isoelectric point isn't really going to be dependent on this one because this is so far apart. It's really going to be at the point where this does not donate its proton, but also this one does. So you know it has to be kind of in between there and there. So you're going to go ahead and add those two up and divide by 2, and that gives you a rough isoelectric point of about 2.77. Again, keep in mind these values, take them with a grain of salt. It varies depending on the textbook and all sorts of stuff. Same thing over here, based on that study, or based on that reasoning, we know that pK isn't really going to depend on this one. The pK, or the PI rather, is going to exist at a point where this one, well, in this, it's going to exist at a point where this does not have a charge on it. Sorry, in this case, it's going to be above this one. So this one is not going to have a charge, and this one will. So it's going to be between this one and this one. So you're going to go ahead and add those two values up, divide by 2, and you're going to get an isoelectric point of about 9.6. So you should note that if the amino acid has an acidic side chain, like aspartic acid, it's going to lower the isoelectric point, and if it has a basic side chain, it's going to raise the isoelectric point. So that's just as a general rule of thumb that will help remind you, make sure you keep that in mind while you're trying to find these. So if you're given a basic, whether it's arginine or something like that, it's going to have a higher isoelectric point than your general amino acid. Okay, so make sure you stay connected. That about wraps up our review of isoelectric points. Please let me know if you have any questions. Feel free to reach out. And here's the contact information of the ASC. Thanks for watching.